Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU actuary. Here's a problem for today for exam P on probability. You are given random variables x and y that have joint density function 0.5 of f sub xy of xy equals 0.5x plus 0.5 minus 0.25y for y between 0 and 1 and x between 0 and 1 and y between 0 and 2 and 0 otherwise. Find the probability that x plus y is more than 1. And there are actually these 5 answer choices. A is 0.19, B is 0.25, C is 0.41, D is 0.57, and E is 0.71. So here's the solution. The figure below shows the rectangle 0.1 x values of x between 0 and 1. So I'm sorry, not 0.1. Interval from 0 to 1 for x values, and interval from 0 to 2 for y values, where the joint density is positive, with the region where x plus y is more than 1 indicated with the dotted lines, and it's the region where x plus y is more than 1, so that it's just above the line where x plus y is 1. Above in terms of y direction, because this region is really y is greater than 1 minus x, and the line that you see there crossing at the x-axis at 1, it's the line where y equals 1 minus x. And the probability sought is calculated by noting that the region over which the integral is taken is established for x interval 0, 1 by the condition that y is more than 1 minus x and less than 2. So that the probability sought is the integral from 0 to 1 for values of x between 0 and 1. And from 1 minus x to 2, that's the values of y from 1 minus x to 2 of the joint density, which is 0.5x plus 0.5 minus 0.25y. So we take the integral with respect to y, and we get 0.5xy plus 0.5y minus 0.125y squared, evaluated from y equal to 1 minus x to y equal to 2. And then we'll need to calculate that, and then take the integral with respect to x. Well, that's equal to the integral from 0 to 1 of x plus 0.5 minus 0.5 times 1 minus x plus 0.5 times 1 minus x minus 0.125 times 1 minus x squared, and the whole expression integrated with respect to x. So we do some calculations on this that you can see here, and we end up with the integral from 0 to 1 of 0.625x squared plus 0.75x plus 0.125 dx. That's equal to well, the first one is 1/3 x cubed times 0.625, so evaluated from 0 to 1 gives us 0.625 over 3. The second one is 0.75 times x squared, evaluated from 0 to 1 gives us 0.71 over 2. And the third one is just 0.125, evaluated from 0 to 1, which is 0.125, because it's a constant. And this is approximately 0.7083, which is answer E. Please remember this is copyrighted material. The problem was created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies, and good luck on the test.